Hello and Assalamualaikum. We are from group 11 and I am Nurul Aklima. I will explain for the task 1 procedure, IO table and also the flow chart. For the procedure, we have 5 process. For process 1, the conveyor at 100.01 will move until the sensor detect the object. For process 2, the gripper 100.02 and drill 100.03 will on the timer 1 for 40 seconds and 30 seconds respectively. For process 3, the conveyor will move until reach the packaging sensor 0.05. For process 4, packaging cylinder moves and counter triggers until reaches 0. For process 5, the change box light triggers and change box button press when the counter reach 2. For the IO table, we have 5 input and 6 output. The input are start 0.00, stop 0.01, object sensor 0.02, change box button 0.04 and packaging sensor 0.05. For the output, we have 6, which is relay 100.00, conveyor 100.01, gripper 100.02, drill 100.03, cylinder packaging 100.04 and LED change box 100.05. When the start button is pressed, yes. The stop button is no. The conveyor will move. When object sensor trigger is yes, the gripper trigger for 40 seconds and drill trigger for 30 seconds at the same time. When the conveyor is yes, it will continue moving until the packaging sensor is yes. When the packaging sensor is yes, packaging cylinder will also yes until the counter reach 0, which means the counter is also yes. When the counter didn't reach 0, means the counter is no, the conveyor will move. When the counter reach 0, which means the counter is yes, the change box light will yes. When box change and button press is yes, it will reach the end. If box change and button press is no, the binary counter increments to count number of boxes. If the stop button is yes, all the system will end and stop.
This is the drawing for automatic drilling machine. It consists 3 sections: start section, drilling section, and packaging section. When the start button is pressed, the conveyor will on and move the object to the drilling section. When the sensor detects the object, the conveyor will off and the gripper will hold the object for the drilling process. After the drilling process ends, the conveyor will on move the object to the packaging section. When the sensor detects the object, the cylinder will extend and push the object into the packaging. This is ladder diagram for shift register. The clear input is to clear data in this address. When start button is pressed, it will give data in H5 and will on the conveyor. When the object is moved to the drilling section, the sensor will detect the object and stop the conveyor to grip the object and the drilling process. The timer will count for the gripper for 4 seconds and the drilling process will happen for 3 seconds. After that, the conveyor will on and move to packaging section. When the sensor detects the object, it will extend the packaging cylinder to push the object into packaging box. Counter is used to limit the quantity in the packaging box. This is ladder diagram for conventional method. When the start button is pressed, the conveyor will on and move the object to the drilling section. The sensor will detect the object and will on the timer or gripper to hold the object for 4 seconds, and the gripper will on the drill timer and the drilling process for 3 seconds. After the gripper release the object, the conveyor will on and move to the packaging section. When the packaging section sensor detect the object, the cylinder will extend and push the object to the packaging box. Each box already set the quantity is 2, so the counter use is to determine the quantity for each box. The change box light will light up after the counter gives signal that the box have already to the quantity of the object is 2. So the operator will change the box, and to reset the counter, the operator will push the change box button after he already changed the box. The make function is used to calculate the quantity of the box.
Hi, I am Din Chi Fun. This is the I/O table. There are 9 inputs and 5 outputs. For 9 inputs, there are clear with address 0.00, start button with address 0.04, stop button with address 0.05, stamping sensor with address 0.06, read switch with address 0.07, limit switch A with address 0.08, conveyor B sensor with address 0.09, spread sensor with address 0.10, and end stop switch with address 0.11. There are 5 outputs. There are conveyor A with address 100.04, single acting cylinder with address 100.05, injector with address 100.06, conveyor B with address 100.07, and nozzle with address 100.08. This is the start and completion table. When press start, the system will start to operate. The conveyor A at address 100.04 will move, and the sensor will detect the object at address 0.06. The single acting cylinder at address 100.05 stamping down for 5 seconds. The timer 2 is complete. Then the single acting cylinder acting off and stamping out. Then touch the read switch at address 0.07. After that, the conveyor A at address 100.04 continue to move until touch limit switch at 0.08. Conveyor A at address 100.04 still move without stop ejector at 100.06 and will push object for 1 second to complete timer 3 to conveyor B. Conveyor B at 100.07 will move when object detected by the sensor at address 0.09. There is a sensor detect object at 0.10 and activate the spray nozzle at address 100.08. The spray nozzle spray for 30 seconds to complete the timer 4. The conveyor B continue to move and stop switch at 0.11. The start button is pressed, the system will start to operate. Then, if the stop button is pressed, the system will end. If the stop button is not pressed, the conveyor A will start running. If the stamping sensor is off, the conveyor A will continue running. If the stamping sensor is on, the conveyor A will stop and stamping process for 5 seconds. Then, the cylinder extraction. If the read switch is not triggered, the process will stop at cylinder extraction. If the read switch is triggered, the conveyor A will continue running. Next step, if the limit switch A is off, the conveyor A will still continue running. If the limit switch A is on, the conveyor A will stop the ejector, push the object for 1 second. Only if sense the object on conveyor B, the conveyor B will start running. Then, if the spray sensor is on, the spray nozzle activates for 30 seconds. Then, the conveyor B will continue to run to the end station. The end stop button on, then the conveyor B stops.
My name is Sean, and this is our CAD drawing. As you can see here, this is the motor that runs conveyor A, this is the start and stop button, and this is the material. So the material will go from this position to here, where the sensor will detect it and the stamping station will stamp it. And then after that, it will continue along conveyor A until it reaches the end of this, which hits this limit switch. Then this ejector will push the material onto conveyor B, where a sensor under conveyor B will detect that there is an object above it, and conveyor B will start. And then it will travel along conveyor B until it reaches the spraying station, where this sensor will detect it. And then it will spray for 30 seconds until the nozzle finishes spraying, and then it will continue along conveyor B until it touches the end of the limit switch. Okay, so now I will show you the task 2 using shift register method. The first round here is to clear any bit from W5 so that we can restart everything from 0. Next, we can press the start button here to start the process. So process 1 shows that it will run conveyor A until it touches the sensor on the stamping station. And then the stamp will run for 5 seconds. After that is done, the cylinder will retract until it hits this read switch. And then conveyor A will continue running. And conveyor A will continue running until it hits this limit switch. which then will run the ejector. Once that is done, we will go to conveyor B. So this sensor will detect that there is an object on conveyor B, and conveyor B will start running. Okay, then conveyor B will continue running until this spray sensor detects an object. Next, after it detects an object, the spray will continue for 30 seconds. And then conveyor B will continue running after that. Okay, then conveyor B will run until it hits the end stop limit switch at the end of conveyor B, and then the whole system will reset. Now I will show you task 2 using conventional method. First, we have a start button to start the system. This starter here is to hold the circuit as high so that the circuit doesn't stop when the start button is pressed. Then we have a stop button here to stop the whole system, and I inserted stop button in front of every rung so that the system will stop no matter where in the program it is running. So the conveyor A will run until this sensor triggers. Then the single acting cylinder will trigger and run. After it's finished, it will retract and hit this red switch. Then conveyor A will continue running until limit switch A is triggered. Then the ejector will run for 1 second. After that is done, there's a sensor on conveyor B that will trigger whenever there's an object on conveyor B. Conveyor B will continue running until the spray sensor is triggered. Then the spray sensor will run for 30 seconds. Once that is done, conveyor B will continue running until it hits this end stop. After that, the whole system will end.